Hi everyone, welcome back to ACER Explained. I'm going through section 3 of the ACER Practice Question booklet, and in this video I'm going through Unit 13. Unit 13 has questions 34 and 35, and as always, I'm going to be identifying some prereq knowledge that you might need, some reasoning skills that you can use, and also bridging our bootcamp resources as well. Unit 13 has quite a lot of information. It has a diagram of a dinosaur and there's a graph, so it's quite daunting at first, but when you break it down, it's really quite simple. So the first thing I would do is scan the stimulus to figure out where I can find information. So in the first paragraph, there's a bit of context. In the second paragraph, there's a bit of explanation regarding figure 1. Then the third paragraph shows the different values, the different letters and what they mean in each of the equations. So we have S is stride length in meters, L is height of the hip above ground in meters, G is a constant, and V is velocity or speed in meters speed in meters per second. Then we have our little graph, and the first thing that I do when I look at graphs is look at the X and Y axes. So X axis, we have fraud number and that little fraction there, and relative stride length is on the Y axis with S over L on the side there as well. Then we have different shapes representing different kinds of animals. Third thing we have is figure 2. So we have the L, what that means in terms of the dinosaur, as well as the speed and the stride length in S. Okay, so we're also given another equation down below, and then we're also given an assumption saying that the locomotion of the dinosaur can be represented by the model described for the mammals studied, including the curve of best fit in figure 1. So that's telling you that if there's any questions about the dinosaur, you can use that graph. And it says use the curve of best fit rather than the individual points. Okay, so then we can move on to question 34. So question 34 says that if the fraud number is 20, so I've put that on the screen there. So we have, this is the fraction that we're given here, GL. That's the fraud number, is 20. And then we have L is 0.2 meters. It's asking what the stride length would be. Okay, so if we remember, all right, well, stride length was in the diagram, but in that diagram, you can't really figure it out because there's no real proportions that are given. So I'm going to go back to the graph. The relative stride length is S over L. And what I can do is I can actually use the fraud number being 20, and I can interpolate in this graph. So I can find where 20 is, which is about here, and the curve of best fit's going kind of like that. And I can use that to figure out what the relative stride length is going to be. And that lies around, I would say, around 6. Okay, so S over L is 6, and we're given L. So we're given S over 0.2 is 6, so I would just go S equals to 0.2 times 6, and I don't like decimals, I always convert to fractions, so I would do 2 over 10 times 6, and that would leave me with 12 on 10, or 1.2. And the closest answer to this is B in my answer options. So I can circle B and move on. And again, for this question, I didn't need to know anything about dinosaurs. I just needed to know how to interpret long passages and visual stimuli and graphs, especially, as well as how to do my basic calculations. And so we have the reasoning skills course there as well, but we also have the calculations and formula acceleration class, as well as the chunky texts acceleration class and the diagrams and visual stimuli acceleration class. And these can be really handy as well if you want to check those out. This question is asking us to figure out the speed at which a dinosaur would change from trotting to galloping. And so, you get that and you're like, okay, well, I need to find some more information compared to the previous question because I'm missing some things. So you go back and you look at your stimulus and you realize, well, you scan it quickly and you see galloping there. So you can say you can see that all of the mammals, they change from either walking to trotting or from trotting to galloping at almost the same Ford number. And so we're given the Ford number for the ferret at which this happens, and that's 2.5. And because we've been given the information that, assume that the dinosaur locomotion can be represented by the other mammals as well, we can use this value here for the dinosaur. And so we have 2.5 is equal to the Ford number, which is this. And now question 35 gives us L, and it gives us L as 1.2 meters. And we also know what G is because it says up near the top that it's related to gravity, which equals to 10 meters per second. So we're just going to use 10 because it's a constant, so that's okay. And so we are left with 2.5 is equal to v squared over 10 times 1.2. Okay, so this we can say is 12 because 10 times 1.2 is 12. And then we can multiply both sides by 12. So we have 2.5 times 12 is equal to v squared. And so let's solve what 2.5 is. So that will be, sometimes for mental maths, I can go 12 times 2, that's 24, and then plus 0.5 of 12 is going to be 6. So that's 30 equals v squared. And then we have to square root both sides to find the speed. So square root of 30. And so what I do when I have an odd, or like a bit of a weird number to square root is that I would think of what square is below and above that number. Okay, so if I'm thinking, let's say I'm thinking 6, because 6 squared is 36. And then I'm thinking 5. So 5 squared is 25. And this number is in between 36 and 25. So I know that my answer is going to be in between 6 and 5. And the only option that fits here is D. So that's how I would go about this in sort of a GAMSAT scenario. Again, no previous knowledge was required here. You just needed to know how to extract the important information from this long passage and how to perform the calculations in a way where you're not sitting there mind boggled about how you're going to find the square root of 30 without a calculator. Okay, so we have a lot of maths bridging course resources on the bootcamp. And then also the acceleration classes with calculations and formula, as well as the chunky text acceleration class, which really help with the reasoning skills that I used here for this question. And that brings us to the end of Unit 13. Thank you for watching, and like, share, and subscribe if you want more GAMSAT help. Please give us feedback. We find that very valuable. And we have our Instagram at ThankFlipGamSat down there, and our podcast as well, ThankFlipGamSat, Nurses Doing GAMSAT, if you want to hear more from us. All right, see you in the next one.